is an architectural designer and energy analyst with a strong focus on sustainable, community-driven design. Her portfolio includes climate-resilient retrofits, affordable housing, and community center renovations in New York. And Anna is dedicated to reducing operational energy use and promoting low embodied carbon solutions while building community power. So welcome. I think I will hand it over to Paul.
Hello, everybody. So we're an architectural firm. We're an integrated architectural firm in that we do a lot of energy modeling and energy conservation as part of our work. We've been working with Passive House for 10 or 15 years. We've been encouraging our clients, our community, the agencies we work with to utilize this tool. And we're at a point in the past couple of years where we're also encouraging our clients to look more at the embodied energy uses of buildings and taking a more holistic view. We're going to present, maybe next slide. I'm going to present New York City, typical tenement apartment buildings. We do a lot of affordable housing work. We work with a lot of the local community groups. These are two projects in the Lower East Side. I'm going to start with these two. These were done about 10 years ago. They were built to the Passive House standard, not certified. A few things got VE'd out, unfortunately. But in our newer projects in the tenement sector, we are getting full Passive House, maybe not certified, but we're building it to the full Passive House. So these projects had, so these are unusual conditions. So we have an existing building. We don't have an opportunity. There's not a lot of opportunity to insulate from the outside. They're generally historic fronts. And our clients and people want to keep the cultural facade intact. So on these two buildings, we insulated the building from the inside, and I know we have to be careful and avoid the freeze thaw cycle. We can go to the next slide. So we're not over insulating on the inside. We followed general building science standards and putting insulation in. We've used mineral wools approximately 4 inches. Our first task on these buildings is to restore the masonry. Next slide. Because a lot of these buildings have been poorly maintained over the years, and this is their opportunity for a major upgrade. This is a project that was done through the Urban Homestaying Assistance Board, along with the funding agency and overseeing agency was New York City Department of Housing Preservation and Development. So here you can see that there's a bit of masonry to be done. All right, next slide. The buildings are also a challenge where on our side property lines, our buildings are butted up against the property line. So again, we don't have an opportunity to insulate from the outside. So we took, and we didn't want to move from inside to outside insulating the building. So we primarily insulated from the inside of the building. We do have some adiabatic walls, but not entirely. And that's a big help. And then the other difficult thing, and sometimes in tenements, is that the existing stair halls or existing historic wrought iron staircases, we can't make those public halls any smaller by insulating on the inside. So this stairway is outside the building envelope. And so we carefully draw a line around all of it. So there's a lot of challenges here. So this building, we did, the VRF system was VE'd out. We do have a gas boiler, highly efficient. The ERV was maintained and stayed into the project. We probably put about 6 inches of polyiso insulation on the roof. We air seal the interior walls. If we can go to the next slide. We used a bit of mineral wool, as you can see here. So the inside and outside masonry walls were restored. These buildings are masonry structures, masonry bearing wall with wood joists on the interior. This building, the joists were all sagging to the center. Many of them failed, so we needed to replace 100% of the existing joists. Next slide. What we did was continuous insulation on all the exterior walls with an interior metal stud, and there's no thermal transmission through the metal stud, because it's continuous mineral wool on the exterior walls. Next slide, please. Here you can see where we have existing joists, new joists bearing on the exterior walls, and we have a thermal break here. So what we did to mitigate that was, the next slide, we filled approximately 3 feet of the perimeter around all the metal joists with mineral wool on the side to reduce the thermal break and the coldness coming into the building. Next slide. Again, insulating all the entire building, the apartments. Windows are UPVC, triple glazed. Next image. Let's see that. Next slide. Let's see where we are. All right, so this is good. So these buildings, these first two buildings, tenements that we did a substantial rehabilitation to a near passive house standard, were benchmarked in the highest 4% of low energy use buildings in New York City. We tracked it for 3 years. We haven't been tracking it since, but we understand the buildings are performing and then the energy use is about the same. We are in touch with the residents of the building. On our new project, we have two different projects going on, and there's always a lot of tenements work that we're doing. So a new project is again through HPD and the UHAB program. It's going to be an electrification pilot project. It's in the construction document phase. It's going to be funded by NYCHA for the electrification. There will be a central VRF system and an ERV system that's staying into the budget. Similar insulation and treatment of the buildings with masonry restoration, extensive masonry restoration, and entire new envelope. And the other thing that we've recently been funded on is we work with a lot of low-income community groups with large portfolios housing. We're working with and we received a NYCHA grant to do an energy master plan for their portfolio of buildings. The majority of their buildings, but not units, are old tenements. And so we did energy modeling for sample, 10 different sample types of their buildings and showed how they can reduce their energy by 70% in these buildings. And then there was another series of senior housing projects that were built in the 60s, 70s, and 80s. Newer type of construction, similar methodology of, on those buildings, we'd be able to insulate mostly from the outside, which is preferable. They don't have historic facades. And again, we're showing a 70% reduction in energy use on those buildings by doing the energy modeling. So we've analyzed their portfolio through this NYCHA grant, which was really useful to see. We calculated the energy use per square foot, both for the residents and for the ownership that's overseeing the buildings. We can see which buildings are using the most amount of energy. And now the group is seeking capital funds to upgrade phase by phase, not all buildings at once. They have a few thousand units. But there'll be a series of phases to upgrade their buildings to passive house or a near passive house standard. Okay, I'm gonna let Vera continue on with this program. Thank you very much.
Great, thank you, Paul. Building on Paul's kind of description of scalable and mass intervention retrofits, we wanted to have a conversation with a case study that integrates densification and retrofits, which are both widely needed in our urban cities today. I will discuss this through the demonstration project, which is called the Beacon. It's located in East Harlem. But first, to contextualize the conversation, I wanted to discuss the importance of both retrofits and densification. While we're all aware that in New York City, the profile of the building emissions is larger due to higher efficiencies in other sectors. So while 70% of the buildings contribute to the greenhouse gas profiles, there's clearly a need for retrofitting them. It's estimated that roughly 90% of the existing buildings will be standing in year 2050. So a mass retrofit effort is going to be needed. In addition to kind of the captured efficiencies of retrofitting, obviously maintaining the architectural fabric and retrofitting adds to the richness of our cities, preserving the historical and cultural assets and adding layers of diversity that we all enjoy about our urban cores. The need for densification, we're clearly in a housing shortage and a crisis. It's also estimated that we basically need to double the rate of growth we currently have to meet the demand. That's really a product of underproduction of our housing sector to meet the rising demand of housing. So through that, I will discuss the Beacon project. It is a project that we're currently working on. It's a product of a HPD competitive RFP process. It's located in the East Harlem neighborhood of Manhattan, between 120th Street and First Avenue. The project team, we're lucky to work with the community builders as the developers, as the co-developers with Ascendant Neighborhood Development. We're the primary architects of both the buildings, and we've also partnered with Zero Energy Design and McGrand Design, who have been our energy modeling partners to kind of quantify the data that I will discuss, that Anna and I will both discuss. The program of this site includes a new construction residential building and a retrofit of an existing school building with an addition of one floor on top to serve as kind of amenity assembly space. The goals of the project are holistic sustainability, which I'll talk about, deep affordability, resilience, and of course, quality amongst all. So as I mentioned, this project is a winning proposal selected by New York City HPD. And the primary factors of proposing the retrofitting of this building, the existing building, instead of a full demolition, was really driven by three factors. One of them was the stated community goals that were outlined in the East Harlem neighborhood rezoning plan that the developers and the design team really aligned to. Secondly, we are lucky enough to have Latier Construction, who is the GC that was part of the early integrated team. They were a part of the team at the very beginning through the RFP, and we really analyzed demolition versus the preservation of the building, and really the cost was almost net neutral, and really the captured qualities of the ornamentation and the added floor to floor heights, we really weren't able to get a new construction. So that was another factor that was really advantageous in the design. And finally, just that idea of holistic sustainability, we're really looking at optimizing the efficiency from the operational side, but also the embodied profile of the site. So moving on to a very high level formal explanation of the site. As I mentioned, there's a residential and a community facility component, and the new construction really hugs the existing building. This site is a product of a rezoning that's undergoing a ULURP process currently, and the site will be zoned to inclusionary housing. We allocated the form really to bridge the context. This is a sandwich between a quality housing building. South of the site, there's a mix of residential, and also a big component was really the Wagner NYCHA campus, which really influenced the design of this kind of tall tower of the planning. We also leveraged the sustainability optimization of the envelope to take advantage of the zoning deductions to again elevate the density of the site by increasing the unit count of the residential portion of the building. Amenities of the kind of this double loaded corridor for the residents. We have kind of ample outdoor space seen in an interior court, north yard, and access to a 16-story terrace. And the interior will have social and gathering spaces, fitness rooms, bike storage, and laundry. And the community facility component really places the needs of the community next to the residential, which is a strong component of densification that we really targeted through the design. The community facility will house nonprofit organizations that serve East Harlem. They'll have shared meeting spaces, and the new addition will have an educational greenhouse and a space that's accessible to the greater community for recreational and activity use. Moving on to the building sciences a little bit, both buildings are designed to meet passive house standards, and the residential component will meet enterprise green communities. The design of the existing retrofit strategy is to insulate from the interior, stud cavity with mineral wool, and fill existing fenestrations with new high performance windows, with special attention to air sealing. And the new construction building is a concrete superstructure, which will have continuous exterior mineral wool insulation and will minimize condensation risk and thermal bridging. I think the key component of this design is really evaluating the affordability with analyzing the data of the energy model, and the building will study integrating double glazed windows really to deepen the affordability and feasibility of scalable approach to these kind of projects. Both buildings will have solar canopies that of the residential building. It's raised to kind of optimize the system. And moving on to the interior of the buildings, both of these buildings are fully electrified, so meaning the heating, cooling, and hot water systems are all electric. The community facility will have a centralized VRF system, ERV, and heat pump for hot water. Obviously, the hot water demand is pretty low because there's no showers. It's really just for kind of very minimal use in that building occupancy. While the residential building will have a high performance electrified systems as well. The thing to note about the ethos of affordability throughout the project is we're looking to integrate individualized heating and cooling approach through the ice, air, cold climate PTAC systems. So the objective of this project is really to meet the passive house performance while lowering the cost. And this will be done through increased air sealing on the site. An additional aspect of the individualized approach versus the traditional VRF system is really capturing the reduced the global warming potential of the reduced refrigerant runs. And the MEP engineer was able to calculate that to roughly half of the typical refrigerants that are seen in a centralized approach. Finally, another key tenet is resiliency. This building site is located in a flood zone. So I think this is something that's key to address in retrofitting, because adapting to the changing climate is definitely a tenet of this design. The beacon elevates all critical building components above the DFE, which is elevated to meet the climate resiliency guidelines, which goes above and beyond the code minimums. And another thing to note is obviously the increased temperatures of our cities. The site is mapped in the highest heat vulnerability index of New York City. So really we're leveraging the passive survivability to provide a healthy and interior environments for the occupants in times of grid outages. And my last point will be really looking at that affordability component of not only the operational of reduced capacity of the building itself, but also the way that we're using these buildings. So we're looking at ongoing affordability and really efficiency in perpetuity. This is specifically useful in affordable projects because utilities represent 25% of the operating budget in affordable projects, whereas it's about 10% in market rate. So we're really looking at how to manage the increased cost of electrified operation. We worked on a Buildings of Excellence Round 3 early design support research study that really focused on reducing the plug loads and the operational use of this building. And taking the most effective kind of low-hanging, most impactful strategies. We hope to integrate advanced energy controls, which will really work with the Con Ed's time of use to effectively manage when the building's energy is used and offset that. And secondly, really incentivize the residents themselves to manage the plug loads. This is done really, we haven't selected a operator, but we've worked with third-party platforms like Meltech, which basically incentivizes the residents to use less energy and avoid peak loads. So now I will hand it off to Anna to discuss the carbon analysis of that was integrated into the study. Thank you.
Great, thank you, Vera. So as Vera mentioned, this project was really researched in part through the NYCHA Buildings of Excellence Early Design Support Award, and through that we have 2 reports that are coming soon, so keep an eye out, focused on the lowering operational energy and lowering the cost of that, but also looking at embodied carbon and new construction and retrofits. So to dive into the embodied carbon a bit, next slide, please. We worked with Zero Energy Design to do the embodied carbon analysis. So as we all know, as we drop operational energy use, the embodied carbon becomes a higher percentage of the total carbon associated with a building. So it's extra important to look at the embodied carbon for high performance buildings. So for this analysis, we did early on in schematic design, and we provided a baseline set of parameters for the building, as well as some material alternatives on the table. And through working with Zero Energy, they were able to use BEAM software, which is good for high-level schematic design analysis, to produce total embodied carbon for each building type, as well as that embodied carbon broken down by material categories. So we have the new construction totaling over 5 million kilograms of carbon equivalent versus the adaptive reuse, which is totaling under 400,000 kilograms. Next slide, please. So if we dive into that a little further, the results aren't necessarily surprising that the new construction would be more carbon, but when you get into actual numbers, it was very insightful. We can see the new construction produces over 13 times the overall embodied carbon of the adaptive reuse. And as we get into carbon intensity per square foot, the new construction still produced over 3 times as much embodied carbon as the adaptive reuse. So why is that? Next slide, please. We looked a little more fine grain at the different end uses for the embodied carbon to see what the highest impact leverage points are for changing the material assemblies. And we see that for new construction, over 85% of the total embodied carbon is coming from assemblies that contain concrete. So that's the superstructure, as Vera mentioned, and the foundations. By contrast, with the adaptive reuse, we're reusing all the concrete elements structurally, meaning that windows now are the dominating assembly with over 67%. Next slide, please. So if we dive in a little further to that discrepancy, which really comes from the concrete usage, this is a Sankey diagram for the new construction building showing that 85% of all the embodied carbon materially is coming from concrete, and is also dominating each of the stages that we considered. So while it's great to avoid concrete when possible, this also brings up questions of how we can start to minimize this concrete footprint even when concrete is necessary, looking into future potential future embodied carbon calculations for increasing percentage of fly ash, recycled slag, or other low carbon aggregates. Next slide, please. Comparing embodied carbon to operational carbon is also a worthwhile comparison. In this chart, you can see the upfront embodied carbon in the horizontal blue line, and operational carbon in the brown, teal, and orange line graphs. So for the new construction, you can see that a code compliant building would exceed the upfront embodied carbon after about 14 years, but by lowering the operational carbon, we can push that timeline out to about 22 years. Shown in the dashed lines are the material alternatives we looked at, and you can see that switching to a CLT system would drop the embodied carbon by about 52%, whereas aluminum windows, as opposed to UPVC, would increase them by about 8%. Next slide, please. When you look at adaptive reuse, obviously all these numbers are quite a bit lower because of the reduced footprint. But we can see that a code compliant the operational carbon of a code compliant building would exceed the embodied carbon after about 2.5 years, whereas a passive house building would exceed the embodied carbon just under 6. And something that was really stood out to us about these material alternatives is closed cell spray foam, which is typically one approach that's on the table for a masonry retrofit, was the worst option in terms of embodied carbon. That would increase the total to, I think, about 15% increase. Next slide, please. So a few takeaways for what's feasible for embodied carbon, especially when budgets are tight. Obviously, reuse the structure wherever possible. In addition to lowering embodied carbon, it makes the impact of other material choices much more impactful, you know, for insulation and windows. But also to do this type of analysis early and repeatedly. So there's different types of analysis necessary at different stages. Our beam analysis was helpful at an early schematic stage, but at this point we are locked into the concrete structure. We won't be switching to CLT. So future analysis could be helpful to understand the different concrete aggregate options, as well as window frame and glazing options. Also consider high impact feasible alternatives. So where design is locked in, can we make material specific adjustments to concrete like were mentioned before? Can we look at double, or is there a big difference between double or triple pane, window frames, etc.? Design options that can happen without overhauling the design team. And then also prioritize strategies with co-benefits. There's opportunities to align restoring historic texture with focusing on strategies that also embody lower embodied carbon and operational carbon at the same time. That wraps up my portion of the presentation. Thank you to Paul and Vera and for PHA for having us.
Wow, excellent stuff. We're going to go to sponsors just in a second here. I just have to highlight a couple things. I love these presentations because I learn things, and if I learn one thing, it's excellent. But I feel really good about my job security, knowing that the amount of retrofits we have to do and the amount of buildings we need to do. And for some reason, if anything happens in Vancouver, I'm moving to New York, because as you heard earlier, the amount of work we need to do. And so you think of Boston and every other city that needs all this material, it is super exciting. So let's go to sponsors.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYCHA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Prosoco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Yes, absolutely. Thank you, sponsors. And let's get into it. Great presentation. Hopefully you guys had a second there to capture your breath and have a sip of water. And let's get into it. We've got Peter to kick us off. Peter?
Okay, thanks. Hi, Paul. Good presentation. I recall you making one statement about common best practices in evaluating the interior insulation. And I do recall from years ago doing roof analyses in climates that are really cold and hot and muggy in the summer, that you do need dynamic modeling to really figure out how to make it safe. Did you guys use any sort of dynamic modeling?
On our current projects, we are using dynamic modeling, hydrothermal modeling. Studies are being done right this minute.
Okay.
for the beacon projects. It is a critical issue. We do have some experience with this, but we do need to know more studies and have a better understanding of how the brick enclosures are working.
Yeah, especially the brick. Good, thank you.
Great question to kick things off, Peter. And again, those earlier buildings, I don't think had as much, data resources that they do now. And I mean, you saw the graphs. Most presentations, we don't like graphs, but those graphs were pretty amazing and definitely made us think about some of our material choices. So great to see that you're incorporating more analysis and more data to make better decisions. Exciting stuff. Bev, over to you.
Yeah, Paul, it sounds like you guys are getting down like a recipe for how to deal with tenements, which is really awesome because I know there's a lot of them. Do you see similar recipes developing in retrofits? And what category of building do you think is going to be next for a recipe?
We are, it's a very scalable, replicable project type. There's tens of thousands of, I don't have the count, but tenements in the city of New York, as well as spread throughout the country. We're learning from every project. Every project does seem to be a little different. And then we are doing more energy modeling on the masonry. Some buildings have a higher quality brick, but there's often a lower quality brick, a more common brick around the sides. And it's something that we've been observing in the projects that we've been doing for the past 3 decades. And we don't see any issues at this point in time, but we're aware of the issues and we're continuously looking at it and to see that there's more modeling done.
Excellent. Thanks, Bev. And over to Valerie.
Yes,
Valerie,
hi.
there you go. Go for it.
Yeah, I had the on my screen, so I didn't talk for a second. My question is, and I'm in the city of Alexandria, so I'm trying to solve a problem of really old buildings that have brick, both interior, exterior. How do you insulate them? And so while we're trying to still figure that out and not have moisture come into the buildings, one of the things that seems to come up though, is that if we're doing this, then we're basically, and you said it, you're insulating from the inside of the building. We can't touch it on the outside because these are historic and we can't touch the exterior walls. So how is this understood by the developer, the owner, that you basically just lost floor area?
Nobody's happy. It's often an argument. Most clients are progressive. Some clients, there's some feedback, and we try to find the tightest solution without losing floor space. Some of the older loft buildings that are the market rate projects that we have, where the apartments are really large, we have the most amount of client blowback. But after a period of time, after we've done a few of these rehabs, our clients do see the results and the huge reduction in energy use, and it makes sense. So it's not overnight, but over time, all of our clients are better understanding these issues.
Okay, and I'm going to put my email in there if anyone has any concrete solutions on how I deal with this particular wall condition. I would love the input from this community. Thank you.
We do have on some of our tenement buildings often an opportunity to insulate from the outside at our rear and side walls that aren't adiabatic. And not every job has that, but we do have a handful of, there's maybe 20 to 30% of the buildings have that opportunity.
Yeah, Valerie, I definitely want to connect with Paul and maybe have more conversations. But if you want a quick resource, one of our amazing sponsors, 475, has ebooks. And so you could download those and you'll see all the details. And so you can start working with your builders in your community by having all the PDFs of wall details and DWG files. So reach out to 475 as well.
Okay, thank you so much. Thank you.
Yeah, you're welcome. Yeah, great conversation. And just a quick segue too is, one of the language that I really appreciate you guys using today was just the cost to quality. And a lot of times we talk about passive houses and, that they're more expensive. But sometimes the language we use and how we can redirect the conversation, just that whole, those cost to quality, I'm going to steal that one and add that to it. And of course, copying is a form of flattery, and we know how we spell the word flattery. So moving along, Houston, you're up next.
Yeah, thanks. I'm curious about the selection to use packaged thermal heat pumps on the Harlem project. I suspect it's economic, and I also think you partially answered the question in your presentation. You call them super efficient, but in my experience, they're not super efficient. The other mitigating factor, I suppose, is the fact that this is performing at passive house levels, so the amount of heating and cooling required is very small. But still, a cold climate VFR heat pump system, the efficiency would be through the roof, and you could probably get much smaller air handlers. Can you address those things?
Sure, I will have the first stab, and then Paul, please weigh in.
Sure.
I think, as you mentioned, obviously affordability is quite key when it comes to this kind of project. The other kind of unique nature of this typology is it's very, very dense. So the loads are, quite heat dominant, but we're very tight on space. As we all know, as we try to kind of optimize the density of these units, the selection of that specific P tag was really a driver in lieu of an alternative that integrates the ERV system. There's spatial implications, and of course, there's some cost challenges that are associated with that. The ERV is planned for the project at this point. We are already code mandated to exhaust for the kitchen and bath, so the risers already exist, and this is specific to the units. And obviously we have the ERV for the common spaces and kitchens. And in addition to that is that the project is going through ULURP, so there's a little bit of an extended timeline, and the process usually takes about 2 years. And we've seen on the market there is quite a bit of optimization that's happening in the equipment sector. So we're really hoping to work with, I mentioned ice air, but really any manufacturers that are available to meet those efficiency and air tightness thresholds. So we're optimistic, and finally, really looking at the projected performance and the utility savings. It really didn't justify the increase in the hard cost for the traditional system. So we're hopeful to really study an affordable, high efficiency delivery through this process.
One thing that's very helpful in having our project successful is working with a general contractor during the design phases to be certain that our projects are on budget and we don't have to redesign at a later point. And I think the biggest factor was the reduction in greenhouse gases in the refrigerant lines that led us to this decision, along with cost. And then building to passive house greatly reduces the energy use that you do need. Heating loads are minimal in a building of this mass with a lot of individuals and appliances inside. So it worked on this project.
Thanks.
Sorry, I was just throwing in the 475 manual for Valerie there. You know what, that's an amazing answer. I thought you were going to throw out the "it depends" real quick. So appreciate that in-depth answer, because Houston, every project's different. There's millions of different choices, and so when you're looking at affordability, passive house, embodied carbon, you start to look at all these different aspects of your choice. I think these particular projects, the level of thought and decision making is through the roof. And again, I would love to be a fly on the wall in some of those integrated design planning sessions of just some of those choices that you had to make, because it's sometimes right or wrong, you need to make a choice to move the project forward. So
no,
great
it's
analysis of
really good working on this project, and we've had the great opportunity of working with NYCHA and receiving a Building of Excellency Award for research on this project. So we were able to study these issues multiple times using multiple tools, WFI energy modeling, and comparing it to the eQuest modeling, and why, examining why there's differences. And so it was a really good opportunity.
Yeah, that's great. Again, appreciate having the getting support, because having that support allows for the data to be getting more team members involved to do those critical decisions and analysis. So excellent for getting those awards. Moving along, Enrique, you're up next.
Thank you.
Great presentation. It's a question for Vera. What was the ventilation strategy that you use on the residential building there? I think you partially answered it before, but was it centralized or semi-centralized or decentralized or?
Right, so we're hoping to integrate the ERV, so that portion will be centralized, yes. And I think that in the chat, I also see some concerns about the air infiltration, and certainly that is the crux of using these components and really the increased penetrations that are seen throughout the entire envelope. That's definitely going to be a challenge that we're hoping to design for and work with our GC. But the unit that I mentioned, we're also looking at the measured third-party tested performance of the air sealing, which is stated to meet the passive house performance. So it's really going to be testing installed units and seeing if they perform as stated. So we're excited to integrate that.
So the ERV is going to be somewhere in the building itself because the roof is already taken by the PVs, or?
The PV system is actually elevated, so it's a canopy system, so it's located on the roof, yes.
Okay.
Yeah.
Okay, thank you.
Thank you.
And just a side question too, Vera, did you guys look at the embodied carbon of the solar panels? I know in past presentations, we're seeing that the embodied carbon of solar panels is quite high. I mean, concrete wins, steel's number 2, but I'm seeing from previous presentations that solar panels are kind of 3 and 4 with windows. Is that kind of what you guys are seeing as well?
Well, I will take the first part of this. So this is an HPD funded project, which mandates that there's a solar where feasible, which the return of investment on the solar was within that threshold. So obviously, as more buildings become electrified, the grid will be somewhat overburdened in our cities. So that's something that has to be balanced with that question that you just asked. And maybe Anna, you can weigh in on the embodied carbon of the solar panels. Thank you.
Sure. So to first directly answer your question, the solar arrays were not included in the embodied carbon analysis. This was only the building like envelope and components and not the energy generation portion. I think it's something we definitely need to be considering in the future. And I think it also speaks to how we need to have the financing of embodied carbon value integrated. Right now, solar and energy generation is really important for optimizing operational energy, and I don't think we've really integrated that kind of financing value of lower embodied carbon. So it's all part of the equation. Thanks for the question.
No, it's great. And again, I appreciate the fact of looking at the grid and again, trying to look for renewable energy versus maybe dirty energy. And so making that choice to fit it in there again is another decision making that is really great in your guys' analysis. So glad that you're able to incorporate that into it. We're going to go to Clara and then we'll go to events. So Clara, one quick question and then we'll get caught up with what's happening with the accelerator the next week or so.
Yeah, I was wondering if geothermal was considered. If I don't want to, I know we're running low on time, so I don't want to take up more time. I just know that the operation bill impacts would be a lot lower, and then you'd also potentially, if you were designing the project today, you'd get a 40% IT, 30 or 40% ITC that you wouldn't get on air source. So just wanted to mention that.
Vera, do you want to take that one or shall I? Okay. The geothermal was extensively studied. It was a consideration for the project. The client, however, had 2 or 3 bad previous experiences with geothermal, and they weren't ready to move forward on this one. And there are great incentives, so it's a consideration for other future projects. Yes. One thing that I want to just really quickly note is that we do a lot of mock-ups and some testing on our projects to be certain that the products we're specifying, especially with the multiple units of the window units, the PHPs, so that they're air sealed and that they're installed properly, so our buildings perform as designed.
Yeah, and Claire, just to add on to your question, I think that part of that study, it was really illuminating to see really how to balance that incentivized structure that's available now, which is really exciting, but also a site that does have a component of different use groups, so residential and community facility, building occupancy, all of course have different user profiles. So we looked at kind of how to balance those two, which was exciting. But another challenge was really the existing building. Although we can kind of drill from the site approach, there was a little bit of complexity that was added in already the flood zone. So unfortunately, not on this project, but we really hope to integrate it in the future and understand that there's a lot of advantages to that.
Excellent. I'm just going to pass over to Bev to get some final words from Bev, and then we'll wrap things up in the hour and then deal with the final 15. Over to you, Bev.
Thanks, everybody. We're at the top of the hour, so just so glad you joined us. I hope you were able to network with some people, and I hope, like me, you learned a ton because this was really interesting, and hope to see you in the future. If you have time to stay a little longer, we'll be answering a few more questions for 15 minutes. Thanks, everybody.
Thanks, Bev. And yeah, thanks everyone that joined. We're going to continue on. We have Daniel out next, but Daniel, just before you hop on, just again, everyone, thank you for showing up. We appreciate you joining us. Again, great crowd. And anytime you hear the word tenements, you know retrofits are going to be involved. And again, from someone being not from New York, definitely know there's lots of history with those type of housing, and the scale that needs to be to work on these buildings is a lot. So great that we have examples of how to retrofit them and also build new passive house buildings beside it to deal with the density issue. So great presentation, lots of in-depth analysis. Love the slide deck, and again, share this with your team and your colleagues so that they get a chance to check out a really great presentation that occurred today. So back to the questions. We've got 15 minutes, so team and presenters, if you can stick around with us, we appreciate it. And let's continue on with Daniel. Daniel, still with us?
Yeah, I sure am. And thank you all again for an awesome presentation. It was super informative. And I guess this is really towards Anna in what you were presenting on the embedded carbon. Just didn't hear that the existing building was really included in your calculation, because even if you were to tear it down, it has some value, and keeping it has the value in it versus, as if it was kind of birthed fresh. I just was curious about that.
Yeah, definitely. So the existing components of the community facility that we were retaining were not included in the embodied carbon analysis. And you're right, if it were a full apples to apples comparison, all of the embodied carbon emitted decades ago would be included in addition to anything that was demolished and shipped off site. And I think the first part of the answer to why we didn't include it is this was really a decision-making exercise, I think, for the stage of the project we are at now, and trying to understand the embodied carbon impacts that our design decisions are going to make, and looking forward, understanding that the carbon embodied in the next 20 years is really crucial. And I do have to say, I think it would be a interesting fine-grained understanding once all the design aspects are confirmed or built, to understand actually what is included in the building, do that fine-grained analysis, and add in the additional aspect of what's already there. So yeah, let me know if that didn't fully answer the question.
No, that was great. Thank you. I appreciate that.
Excellent. Okay, carrying over, we've got Eric. Eric, you still with us?
Yeah, I'm here.
Go for it.
I think my question is envelope centered. Sorry if I wasn't paying close enough attention at the beginning to realize whether you took the brick off and replaced it or not. But I'm more interested in the decision process of how do you weigh the perfect solution for the envelope against preserving the exterior cladding. So if you could speak to, like if you want to get a continuous air barrier and rain screen, then you have to decide whether you're going to keep the brick or not. So if you could speak to that.
Yeah, good questions. There's many other PAC projects that we're working on now, NYCHA projects we're retrofitting and examining those issues now. There's a lot more data and studying that we're doing and analyzing each different type of brick. On the retrofits, an extensive amount, but not all of the brick was repaired. Mostly the common brick was in poor shape, and that was restored. The face brick was in excellent condition and of quality, so that remained. We based our data on the project 10 years ago on an analysis that other people have done and reports that were issued, and it was generally felt that a 4-inch mineral wool type insulation was, keeps the building within a reasonable freeze thaw cycle. And we do see that the buildings are maintaining well, and there are no issues.
Oh, okay, thanks. But I honestly, must be a much greater challenge for you to get real good air tightness if you're not going to strip the cladding off, right?
So air tightness is we're coating we're using a permeable coating on the inside masonry walls. If we're insulating from the inside. If we're insulating from the outside, we'll do further analysis, but we would generally put the coating on the outside.
Thank you.
Restore the brick and then.
Yeah, Eric, that air barrier on the inside definitely is a challenging approach. But when you take on a heritage project and you take on a retrofit, you're setting yourself up for a challenge. And the fact that they've been able to do this and have repeatable systems and just the in-depth decision choices that have gone on here is remarkable. And I think your air barrier solution is probably easier compared to some of the other challenges you guys faced on these projects, which is great. So yes, when I ever hear the word tenements, I will hear of historical projects and heavy lifting that needs to be done to bring these old historic buildings back to the modern era. So exciting stuff. I had a question just because mass timber, wasn't a choice, and I appreciated the analysis you had of, the reduction of your embodied carbon if that was a choice. Are you guys advocating for it? And do you have some people around that are working on policy to see it? Or for now, do you feel like, looking at concrete solutions and lower embodied carbon concrete is kind of like your 2 or 3 or 5 year plan, while, mass timber will maybe be future planning for structural material?
We'd be very excited to see our codes updated in the city of New York for mid-rise construction for CLT and mass timber. There are some permitted structures, but certainly not in the high-rise category. But you will see it in the mid-rise, and we are promoting it and encouraging it with the different agencies we're working with.
Yeah, great stuff. I mean, it's nice to see that. I think Milwaukee is going to take over the tallest mass timber tower at 28 stories. I can't keep up. I know it was Cleveland, now it's Milwaukee, and maybe Vancouver. So exciting, in the superstructure world. But we definitely find like that 8 to 12 story is a sweet spot for density, mass timber, and and material choices. So exciting times for us. Was full on. We got great value today. I definitely took away some new language to use with some clients. And I think Kim, we're ready for you to hit the ejection button. So enjoy the rest of your day. Take care, everyone. And we'll see you next week or on a podcast.
Take care.